It's time to learn about graphing position. Here are our objectives. To visualize an object in motion, we'll often use a motion diagram, a representation, typically a dot, which shows the position of an object each second. In physics, we don't draw rocket ships or cats, we just draw dots. These dots are a cat on a rocket ship. Understanding that each dot is created each second, we would say this object, perhaps it's a shark, is moving at a constant speed. But what about this object? How would we describe its motion? This object's position isn't changing much initially, but then it travels further and further each second. This is an object that is speeding up. What is this one doing? This time it travels very far after 1 second, but then less and less. It is slowing down. Time began with the Big Bang, and ever since then, things have been moving. But we can't measure everything from the beginning of time, so what we need is an origin, a point on the graph which represents a specific place at a certain point in time. The origin is found at 0, 0 on the x and y axes of a coordinate system, a system which uses time on the x-axis and a variable like position on the y-axis. All graphs must include a title, a label for the x-axis, and labels for the y-axis. Notice the units, meters and seconds. Reading units is so important to understanding graphs. So what do we see happening? Well, each dot represents 1 second in time, so a lot of people might say it goes from 0 to 10. But it's better to describe it. An object begins at 0 meters and moves to 10 meters in 5 seconds. And then what does it do? The object travels south, going 20 meters in 5 seconds. Can we calculate how fast it is going at each point? To find velocity, we'll measure the slope of the line on this position time graph, using the equation for slope, which is rise over run. At A, it travels 10 meters north in 5 seconds, giving it a velocity of plus 2 meters per second north. At B, it travels 20 meters south in 5 seconds, giving it a velocity of negative 4 meters per second south. And what does this crazy object do? At A, it travels south to negative 5 meters in 4 seconds. At B, it stops moving and stays at negative 5 meters for 4 seconds. At C, it teleports to a different location in 0 seconds. This is impossible. And at D, it travels back in time to the beginning, which is also impossible.